Let me see if this guy started. Yeah, it started recording. Yeah. Okay. So what we want to do here basically is that we want to go and say, you know, okay, there's two pieces to this. There's the piece that takes in the OData query.
Yeah.
And then turns it into an expression tree.
We call it abstract search tree.
Yeah, the AST, is that what you call it? AST.
Yes.
Right? And then there's also something that takes this AST and turns it into a query, back into a URL query, right? We can do that, right?
You mean AST to the HTTP URL query?
Yeah.
Okay.
Yeah. So, you know, let me say URL query in here just to clarify. This is URL query, like this. So this URL query, let me just make things a little prettier for people that are watching this. There we go. And then there's this guy, and there's this guy here, and this is the URL query right here. This URL query. Okay, perfect. All right. Now, let's put this guy up here, and let's move this guy up here, and now we are in a good state. So what are we trying to do, Sam? I'm trying to, let's see if we can extract the URL query and then turn it into AST and take that AST, right, and turn it into an IEnumerable or an iQuery.
Yeah, so you need another circle.
Yes, we need another, exactly. So we need a circle here in the middle. And that circle basically is the one that goes and says, let's see in here. It'll look something like this. This one here is, we'll say AST2 2
link expression.
Link to link expression. That's right.
Yeah, link expression.
That's right. To link expression. Let's just say link for now, right? And the same thing is going to happen on the other side. What that basically means is that, so there's some mapping happening in here. So we're basically going and saying, okay, I still also want to take that link expression and turn it into AST, right? And AST will take this and turn it into a URL query back, right? So this way, basically, we can achieve the goal of transient or transcendence. You know, when it comes to OData query, we can pass this between microservices, you know, without any issues. But we want to standardize this, and we want to basically extract these components so people can embed that in their URL clients, your HTTP clients, you know, be able to extract that information and pass it downstream to other services and break it apart. Let's go and take a look what that would look like, Sam, you know, from a high level perspective. So let's go into GitHub here real quick, and let's research that stuff together. Let's go into, so here's OData, and I think that would be an OData net, right, Sam? Oh, sorry, net, yeah.
Yes.
And then in your source, if you go into the core piece, and then under URI, I would,
parser.
URI parser, right? And you got all that good stuff, right? This is all the URI parsing stuff.
You can see there's OData URL query parser.
Yeah, OData URI. This guy? That guy.
Yeah.
All right, my friend. So each one of those is its own clause, basically. And these things, these class that you're creating, is that what you call an AST?
Yes. You can see there are a lot of class. The apply clause, create clause, order by clause, compute clause.
And you got all of these.
That's in-memory representative for the query option.
That's
passed
right.
from the URL OData query option parser.
Gotcha. Gotcha. And all of these things that we have in here, what we can do, so these are all the options that parser filter, parse apply, and I remember that you have like an apply method in here that can basically go and say, yeah, the apply.
Apply method is a source code in the web API side. So go back to your George.io.
Yeah. Okay, let's go back to draw.io. Go back here.
So the first cycle, URL query to AST.
Oh, so URL query
to AST. It's happened in the OData.NET library.
Yeah, this guy is an OData.NET library.
Yes.
Data.
We can call it OData.core. OData.core.
OData
so
core.
The project name is OData.core.
Yep, gotcha. Yeah. That guy right here.
So AST to link, link expression, so far it's in the web API, or we call it AspNetCore, OData.
Oh, OData.
We can call it AspNetCore OData or web API. Yeah.
Like this? Okay.
Yeah. And the repo is, we have 7x is the repo name is web API, and the 8.0, the repo name is AspNetCore OData. So later, when we go back to the GitHub, I will share it to you.
That's good.
So,
that's
okay.
Good. Yep.
So link you to the URL query.
Let's see. Let's first start with this one, Sam.
Yeah.
So we have an AST. So when you say this AST representation, right? AST representation.
Yeah.
Is this one object or multiple implementations? Like what does it represent? Like in here, for instance, you're going and saying, I want to return an apply clause, and I have a search clause.
Let's have a filter clause as an example. Filter clause up
like this.
Yeah, line 20.
Line 20. This guy right here.
Line 30.
Line 30. Filter clause.
The filter clause. Can we go to the source code?
Yeah, let's see if it will let us. GitHub has this new thing that lets you go to the source
code.
You
can copy that.
Copy.
And type T.
Type T.
T.
Oh, like this? Ooh, magic. Okay, and then we can do this. What do you think about that? And then we can go up here and let's see what that.
So you can see filter clause accept the expression and also accept a range variable. So expression is a single value node. So it means you can have a lot of single value node is an abstract class for all of the node, and most of node class derived from single value node.
That's right. That's right.
So for example, if you have $filter equal ID EQ value, so the single value node is a binary search node. So if you type the T again.
Okay, T again. Okay, here we go.
Type T again.
Yep.
Let's type binary. Binary. So yeah, so binary operation node second one.
Yep.
You can see binary operation node is a single value node. And the binary operation node has a left and a right. So binary means it's for example, it's EQ or LT or
that would
GT,
be the left.
Is something like this. So you can we have the left part, right part, and the operation kind. Operation kind is the operation. For example, it's equal. Can you search the binary operation kind again?
Yeah, absolutely. Yep. Binary operator kind. There it is.
Yes, you can see there's a lot of and EQ, not EQ, greater than
everything. All the capabilities.
So, yeah, all the capabilities.
Yeah. I didn't even knew you had
Yeah, binary operation node is one of the example of a single value node, and it can use in the filter clause.
For which one, Sam?
I mean, binary operation node. Binary operation node. Yeah.
Let's go back to this guy.
Kinds.
Binary operator node.
No.
This guy.
Yes, this guy. See, it's one of the single value node derived from single value node, right?
That's right. That's right. That's right.
And in the field clause, the constructor of field clause accept a single value node. So binary operation node can use the parameter to construct the instance of field clause.
Gotcha. So hold on, Sam. Let me visualize these things. Okay, let's visualize these things a little bit. Let's go back here and let's do this, my friend. Okay, so you have this binary operator node, right? That's this guy.
It's
and this guy
from a single value node.
Right, it's driven from the single value node. Let's go up in here and let's just say that this guy is coming from single value node like this. Right? So this guy is driven from this guy, and then this guy has right and left. Right?
Yeah.
So there's right. Left. Yep, there's right, there's left, and both.
And then there's an operation kind.
That's right. That's right. So and the operation kind, which is something that sits in between the left and right? Because basically you're saying, I'll tell you what I understood and let you correct me if I'm wrong. This here is the binary operator kind, right? And in here you have left, which is single value node, right? Single value node, right? And this guy.
We check the code again.
Yep. I'm coming right back to it. SVN. Let's go back here. Here's the code. This guy. So you have single value node here and single value node here.
Yeah, so single value node again. So it means you can have a lot of nodes to assign a left and right.
That's right. Just a single value. So Sam, here's my question for you. Right? Here's my question. So when you go and say, let's just take a look at this guy. When you go and say, select, is select a single value node to you, or is it multiple value node?
Here we.
I bet that's what you mean. If you say, yeah, I see what you're saying. This is name, and this here would be
$field equal name. You can use that like this clause.
Like this, Sam? Like this?
Yeah, like this.
So this is basically what this URL breaks down to. When I go and say filter name.
Filter.
What's that, Sam? Go ahead.
Filter. Yeah.
The filter. Oh, or the filter. Yes. So the filter. So where does the filter go? Is the filter the binary operator itself, or what is the filter?
Filter is binary node is one of the property for the filter clause.
So it's it's a property on the filter clause. Gotcha.
Clause. Yes.
Yeah, gotcha. So that means that these guys, all of this falls under, if I go back in here, this is really beautiful, Sam, by the way, this is great stuff. If you go up in here, and if I go and say, give me the
filter clause.
Filter clause, right? Yeah. This guy here, and this filter clause should definitely have a single value node.
Node, yes. And another property named range variable.
Right, and these are the variables that you, a parameter for expression. Yeah. For what? For what, Sam? What was that?
It means give you a variable for the dollar clause. It's just like a lambda expression, the parameter, in a Lambda expression. So it's a variable.
Oh, gotcha. It's
just
basically
like,
So basically, when you go and say, let's see if people would understand this, and I understand it first, you're basically going and saying, for this range variable that you have in here, right? For this range variable, let's take a look at it first before we do anything. Let's take a look at range variable that you have here. This is range variable, Sam. It has a name.
Yeah.
And it has a type reference.
Yeah,
and it
it's
has a
just
kind.
like, so range variable is things like I type something in the chat.
In the chat? Okay, let's take a look. So this here, what Sam wrote, let's take a look. Here's a note. It's like a Lambda expression. That's why, let me go back here. This is what basically Sam was saying. So this is, so this, I know that this here.
This is a property, right? So this is a field clause.
Right.
And E here is a variable.
Yeah.
So we can call it a range variable.
Range variable, okay. Gotcha. Yep. And name is the property and Sam is the value, basically. Right.
And Sam is the constant node. So if you go to the OData code, Sam is a constant node, and the name is a single value property access node.
Okay, so Sam would be. Let's go back to the filter
again. So constant node.
Constant node. There it is.
Yeah. So it means it's a constant value.
That's right.
Constant value is object. It can be string. It can be integer. It can be anything. But it's a constant.
That's right.
So the name, because name is a property, it should be a single value property access node.
That's right. Okay. So this here, let's take a look here, Sam. So you have all of that good stuff in here. You have a visitor. Okay, perfect. Let me go back to the filter clause real quick. Filter clause. This is AST.
So field clause has a expression and the range variable. And for the example, name equal Sam, something like this. So the expression itself is a binary operation node. And the binary operation node, the kind for the binary operation node is equal.
EQ.
The left side is a single value node again. So the left side is a single value property access node. And the right side is a constant node.
Right. That would be the name, Sam, right? So if we go back to this one, that would be name equal Sam.
Yes, the right part, the right is a constant node again.
Yeah, that's a constant node right here.
The right is a constant node.
Yeah. This guy here is a constant node.
Yeah. And the left part is a single value property access node.
Nice.
I think so. Node.
And EQ is kind, right?
It's kind.
Yeah. You call it operation kind or just kind?
Kind. You can call it kind. So.
Yep. Okay, got it.
And so, yeah.
Now,
because the left part accepts a single value node, it can be anything. So if you have a field clause like this one, field equal name equal Sam, and ID less than 5.
Okay, let me copy what you just wrote. Sam here is writing a little piece. Take a look here.
LT, right? LT, sorry, LE.
Yep. Let's go back here. Let's go back here. So what you typed is basically this piece. Filtered name equals Sam and
ID LT. So,
LT less than,
LT,
right? Less than
LT 5.
5, right?
So, yeah, you can see dollar field is it's a little bit complex. So here is another, the top level is a binary operation node. The left side is another binary operation node. The right part is another binary operation node. The top level kind operator kind is AND. The left binary operator node is equal, and the right binary operator node is LT. So it's just like a tree.
Yeah, I see what you're doing. This is Sam. This is genius. This is really beautiful. I can't wait to see how we're gonna turn this. But what you basically are saying is that if this is your expression here, if this is the expression, then this guy would break down into this. You would have this guy and this guy, and then each one of them will have their own operations, right? So this guy, it would be like this, like this, like this. If you just bear with me for a second, I'll be as fast as possible. And then you have this guy here, and they have this guy here. You're basically building an entire tree. Let me copy that guy here. Let me throw that guy out. So you have this guy like this. And then at the very top, let's zoom out a little bit. At the very top here, you have another node, right, that combines both of these together. And there is also a kind in here. So the kind can be something that lives at the level of what you call the binary operator node, right?
You
So
can say the kind is just the information in the top level cycle. So you can in the top level you can remove the cycle. Yes,
remove the
you
circle
it,
like this.
yeah, no, keep this one,
and just remove this one.
remove this one,
and
and remove
just
the
type
arrow. Yeah,
and.
add, yeah, and do the
Really?
thing for others.
But these ones would be
EQ,
but just
EQ.
EQ. Oh, okay, I see. So that I see what you're doing. So this guy would be the kind is what actually connects. So in your
And
case here, it would
LT,
be LT,
yeah, and
and
remove the
in,
cycle.
yeah, you don't
Remove the
need that guy. I see what you're doing. And then
So
in here
it looks like a binary search tree.
yes, you're basically going here and going like this. But let me ask you this, isn't in binary search trees, let me ask you this, what are you searching first? What are you trying to search for? Because isn't in binary search trees, you have the left side lesser than this guy and the right side larger than this guy?
Yeah, use this structure to organize the information, so you can see it's if it's a binary operator, it always have the left and the right, and also you can find the operator. So in the if now we have the structure like this, and in the BBPR or in the AspNetCore, we can take this structure and we can take this structure and to build the link expression based on the structure.
That's right. That's right.
I mean, it's totally different if you add how to say it? Yeah, we can change the order.
That's right. You can change the, yeah, it's not binary tree in the sense that, it's trying to enforce a certain rule on what's bigger, and it's not really searching. It's just that it's just information structure. I see what you're doing. You're just structuring the information in a way where you can compile it and work with it without having to worry about, you know, um, thinking about how you're going to structure that data, which is, by the way, Sam, it's beautiful. Now let me ask you this. So now this one scales because you can go forever, right? You can go for days, but let me ask you this. What if you have a third? So you have and, right? Does the third one go? Does it look something like
No.
this?
If
Oh,
you have
okay.
another and, so you
Yeah.
can since it's still a binary search. So if you add another,
Keep going.
no, it's not this type. So if you change the query string, so you can add another and
Yeah, and let's
after
say
and
let's say and
age
score
age
age
or age
greater than 20.
20. Yeah, it's okay.
Yep.
So now it's separate into two parts. The first one is the first and. The first and has the left side is equal. The right end is another and.
Okay, there's another and at this level, atop from this level.
Not this level, in the right side of this and.
Oh, in here,
So since this is an and again.
This becomes an and. I see what you're saying. Okay, hang on. I know what you're doing. Hold on. I think I know what you're doing. You're going like this and you're saying you want to do it like this. Then that node will move down here. And then that node will live up here.
Yeah.
And now you have, I see what you're saying, Sam. So this guy is in here, and now this guy is and, right?
Yeah.
And this guy stays as L, except that this guy here is age greater than, right? 20. Is that what you're saying? Like this?
Yes. Yeah, it depends on the order. So if you change, you can add parentheses to change the order. But if you without order, I think that's the structure. I'm not sure which one is a higher procedure, but this is the structure.
Yeah.
Maybe it's separate from the second end. But I think that's the correct. I'm not sure. Maybe
So that,
but the structure is similar.
the structure is similar to that.
Okay, so it's another tree. It's a tree.
Yep. Another tree, just like so let me ask you this. So this is how it scales. So if I add another and, where does it go? Still under these two, right? So it scales in this direction, this red, or does it go in this direction?
Yeah. So it depends on the order. How to pass the order. So in the query expression. So I'm kind of remember the order. So it means it's just like algorithm, arithmetic.
Yeah, it's like arithmetic.
So
You honor the
you can
multiply
3
before.
minus 2, 3 minus 2 plus 3 minus 2 times 5.
Yeah.
You can say it 3 minus 2 times 5. So which one is calculated first? You calculate the times.
I think the times first.
Right?
Yeah, that's right.
Yeah.
So two times
But
5 is
if you
10.
add the parentheses before 3 and after 2.
That's a different story. Then you're basically changing the order.
So if you add a parentheses like this, you change the order.
That's right.
So it's same as in the OData, you can add the parentheses, change the order. It's up to you. But to be clear, this is the same expression, but the structure is totally different. But however, it's also, no matter how do you change the expression, it's a binary tree.
That's right. At the end of the day, yep, it'll end up being a branch on a binary tree, right? Okay.
Yeah, it's a binary tree.
Let's not worry about the order for a second. Let me just ask you this. So that means if you get another and, Sam, what basically happens is that this right branch is still gonna
If
continue.
you add another and,
Uh-huh.
so for example, you add another and, I think the and will go to the left side.
Left side. So you're gonna balance. You're gonna keep
You try to
balancing it
balance
this
the
way.
binary tree.
Gotcha. I see what you're doing. I see what you're doing. This is fantastic. This is beautiful. Well, in that case, then what basically happens is that, you know, you basically, you know, try to balance the tree and then you manage the expressions based on the order, right? That's what this is, right? It's based on the order. Or does the position on the tree doesn't dictate the order in any way, shape, or form? It does, doesn't it?
It does.
It does, right? Or it doesn't?
Yeah, it does, I think.
It does. It does. Okay. So basically, you're starting from the left, all the way from the left, like you would evaluate this first, and then you will evaluate this piece first, and then you will evaluate this piece first, and then this entire piece,
Yeah,
right? And
yeah.
then
So
the entire expression.
I think the location or the position of the expression determines the value to evaluate. However, as a arithmetic as an example I gave you,
Yep.
you can add the parentheses to change the order.
Yep. I got you. And based on these parentheses, it will order the items or
So, for
these.
example, you can add a parentheses before name and after 5.
Before name and after 5. There you go.
Yeah.
And after 5, that means that this branch is gonna
It
go all
means
the way up here,
yes. So
right?
it means yeah, go to the left.
Yep. Gotcha. I see what you're doing. So basically, this guy here, like this. Hold on. This guy here will leave this branch completely, and this guy will disappear like this, like this, like this. I'm gonna push this guy up a little. Then you're gonna throw this guy in here like this, and now all of the sudden, this tree branch here is basically, you're gonna have an and living in here. And this and will be talking to this branch, and this branch is basically gonna be talking to these two branches, and then later on, after this evaluation have happened already, it goes right in here, right?
Yes.
Okay. All right. So there's this piece. This is amazing. This is really beautiful. And I'm assuming the order would be as I light up things right now, Sam. So it starts like this, and then like this, and then like this, and then it starts from the bottom to the top. So it's traversing from the bottom to the top. So I'm assuming it goes like this, huh? Like
Yes.
this, and then like this, and then it evaluates to this guy. And now that this guy is done, it starts like this, like this, like this, and then all of a sudden goes all the way to the top, and then it gives you the final evaluation.
Yes.
Is that right? That's
Yes.
amazing. Now, the thing that, would make us want to think about, okay, we want to take that expression tree, sorry, that binary tree, and turn that into a link expression. So there's
Yeah.
two steps like you were saying earlier. You were saying, okay, you turn this into AST, and now that AST needs to turn into link. Let me first ask you the link. Yeah. So let me ask you this question first. Do we um do we have something outside of the box that does this conversion in our code base today?
Can you say it more? What do we?
Yeah. So do we have anything in our code in OData.NET that takes AST and turns it into link expression today? Like, do we have something today?
In the OData.NET,
Yeah,
no,
it's in the Web API project,
it's
isn't it?
in the web API.
Let's take a look at this guy. Let's see what it does. Let's take a look at it. So this guy lives over here in the Web API. Is it? Do you mean the ASP.NET OData core
Yeah,
OData?
maybe this repo is easy for us to go through the code.
Yeah.
OData.
So the ASP.NET OData. Okay, and this guy, let me do the search here. And what are we looking for here? So let's take a look at the a tree structure first. So in here, you have OData,
query,
and then query.
Yeah.
And then
expressions. So we have the field binder.
The filter binder, right?
Yeah.
This guy.
Yes.
Okay.
You can see there's a bind method. Control F.
Bind. Control F. Bind. The entire project. Yeah. Parentheses. Yeah, there it is. Bind.
Yeah. So we can go to the next one. So binder is a static method. And it takes the equalable and using the field clause. So we talked to the field clause,
Yep. We just talked about it. Yeah. Yep.
And try to bind. So you can see we bind the field clause, and let's go to the bind the field clause.
Yeah, let's take a look at that guy. So this guy here it is.
Field clause.
Yeah, there it is. Bind filter clause. And it takes in a filter clause, filter binder, and a type. It must have converted, like if I go back here by
bind
one.
Expression.
Yeah. So one sec. What did you do with this base query, original base query? You took that base query here.
Yeah, we don't care about what's in the equalable. It's equalable.
It's empty. It's just
it could be anything from the database, and it could be an output from another binder.
Gotcha.
So, yeah.
Okay, this is the function, and this guy returns a Lambda expression.
Lambda expression. So that all the expression class defined in the system.linq.expression.
Right.
So we take the field clause and convert that or build that into a Lambda expression. So it seems we have $field equal name equal Sam. We try to build a function called like Lambda expression like E. I also type that E.
Fat arrow and then E. Yep.
E dot name equals Sam, something like this.
And this Lambda. Go ahead.
Yeah.
Go ahead.
This Lambda expression.
Yeah, this Lambda expression that comes back, let me try something with this guy. Like if I go here and say, one sec, Sam. If I go
we
here.
can go to the bind expression.
The binder expression where?
The line 55, 75.
75, this guy. Bind expression.
Yeah.
This guy. This is where the magic happens. It takes in a filter. Go ahead.
Go to the bind 538. There's
This
a
guy.
bind. So we go to the expression bind base. I think the third one, yeah.
The third one. Okay, let's go here. Oh, this is just an abstraction.
Calling node. Can we go to? Can we search bind? Control F.
Yeah, bind.
Bind parentheses, open parentheses. Yeah.
Oh, bind and okay, gotcha. There's this one.
Another one.
Here.
Another one. The next one.
It's the two.
Let me see. Only expression field boundary. Bind. Give me a second.
Okay.
Yeah, let's go to the filter bind again.
Okay, let's go to Filter bind, right?
Binder, yeah. So let's go to the binder, binary operator, binary. Binder, yeah, binary, yes.
This guy. Binder binary operator. Wow, you got
Yeah,
them
so
all
we
in
can
here.
see, yeah, so it's just for example.
Yeah. Uh-huh.
So binary operator node is a class from ODL, right? So we
That's
discussed
right.
that.
Yep.
The binary operator node has left side and right side.
That's right.
So at the line 434,
Yep, this guy
let's
right here.
bind the left side first.
And it turns it into an expression.
It's the left, and bind the right side second. When we finish the left and the right bind, and we will take the bind operator node, binary operator node. So let's go to the
This guy here. Say. Okay.
Go down. So yeah, so take the operation kind and create a create a binary expression. We take the first parameter is operation kind. Take the left expression and the right expression and create the binary expression. Let's go to create binary expression.
Let's go to it. There it is.
Yeah. So take care. Skip the type. So the top the beginning code try to get to the type cell type. We don't care about that.
Yeah.
Go down. Yep. So go down. Yes, go down. Yeah. So if we greater than okay, we
So this is all your validation work you're processing all the way down to here.
Yeah, so we here the line 20, yeah, so make binary. So expression make binary is a API from .NET. We call expression dot make binary and create a binary expression.
Yep. So this here make binary expression. This guy will return a binary expression, right? So at the top.
Expression.
Gotcha.
But expression is a abstract class defined in the system.linker.expression.
That's right. And that guy, one sec, Sam. This guy is what you return as an expression. And this expression is what you actually can pick up and apply to any, like I use expressions myself, but this expression is what you can use to apply to any iQueryable if you want to, right?
Yeah,
and that guy, go ahead.
You can search the iQueryable interface.
iQueryable,
I mean, let's go to the definition of iQueryable.
Oh, the definition of, yeah, absolutely, yeah. .NET source.NET. You go to source.NET, and if you do iQueryable, queryable, here is your well, it's link expressions, right? And this is all
first one.
Yeah, this guy here, it should be riddled with expressions. There it is.
No, up. This is the query provider. So iQueryable has a scroll up.
Yeah.
This is iQueryable. So iQueryable takes the expression as a property and a provider.
That's right.
So at the web side, we will create an expression and apply that to the iQueryable. And how to use the expression is a responsibility from iQueryable provider.
Yep.
To translate expression to a SQL or to a database SQL statement is in charge of from iQuery provider.
That's right.
At Web API audit side, we translate the AST abstract search tree to the expression and save that into the iQueryable or linked to the expression.
That's right. So Sam, you create this. Let's see, this is the code. This is it. You go and you basically create a, give me a moment there. you create this, single value node, or, whatever is a container of these, and then you turn it into an expression.
Expression.
This is what you were talking about.
Yeah.
Actually, I remember in our last, you turned that into an expression.
Link expression.
Yeah, link expression. That's right. That's right.
It's okay.
Yeah, that's it. Expression. And this is where you go and say, yeah, now I have that iQueryable. I can do whatever I want with it. Let me ask you this real quick. Go ahead. Go ahead, Sam. Go ahead.
You have the link expression, and you can apply the link expression to the iQueryable. And iQueryable has a query provider. So when, for example, EF call or EF takes that iQueryable and
Turn into SQL.
Or will take the link expression.
That's right.
And call iQueryable expression. iQueryable provide to translate the expression into the SQL statement. Can you go back to your iQueryable source code?
Yeah, absolutely.
So that's the iQueryable provider.
Yep, let's go over there. There, let's go there. This iQuery provider.
iQuery provider, you can see create query based on the query version. I think there's execute. So line 77.
Line 77.
Line 77. It's
this
execute.
Guy. Execute. Yeah.
So this guy takes the expression and executes that expression on a database and returns the object.
That's right. And the object is whatever it maps to based on
this process takes the expression, executes the expression on the database.
That's right.
Return something.
That's right.
So this is happened in this happens in the query provider. Takes the expression, executes the expression at database side, and then returns the final result.
Exactly. Exactly. Well, let me ask you this, Sam, because we're gonna try to, maybe in our next session we'll try to take that code out, individually, and try to actually build a neat, tiny library that people could just use where they can get that iQuery. Let me ask you just real quick first. What about the way back? So let me jump back into our, let me jump back.
Go back to Joe.io.
Yeah, the way back, Sam. So this guy, this expression, okay, let's say I have this expression object in here, or iQueryable, whatever. Let's say you have an iQueryable in here. And I want to take that iQueryable and turn it back into this AST model, where I can take that AST and turn it back into link query. So you convert it into iQueryable, and now we want to turn that back into an AST model where I can pick that expression. You see how Entity Framework picks up iQueryable and turn it into SQL expression? Do we have something today where I can pick up this iQueryable and turn it into an OData query?
Yes, we have the OData client. Take the link expression. So for example, you can call select x blah blah x dot name. So
here's OData.
OData.NET.
OData.NET, and then there's a client, source, client.
OData.client. Third one.
Yeah, this one. And then I think you might have that in the what's a link, Sam? Is that what it is?
Yeah, I think so.
Add new in
I'm not familiar with a lot of code, but I think this is for example, select expand path visit, remove white child visit.
Select expand path builder. This guy here. So this guy basically takes in. It's very anemic, by the way. It's really anemic model.
You can clone the code and read parts of the code. Clone the soft project.
Like look for a particular object in the code?
Yeah, there are a lot of code in the OData client. is from OData core label. So in the project, we're using the external link to link the C# file from the OData core project to the OData client.
Right, right.
So from the photo or file constructor, sometimes you can't get all the code for the client.
Gotcha, gotcha.
You know, some class, some classes are reused
Referenced.
both in the OData core and OData client.
Yeah, shared. Yeah, shared libraries.
Yeah.
Um,
You go to the OData client folder again.
Yeah, one sec. So source, client.
Yeah, click the C# project file.
CS Proj. Yep. CS
Yes,
Proj. And that guy will have all the references basically. So you're copying OData. So here, this is a simply name. Let's see. Whoa, you're okay. This is
we have the combined.
okay.
Start from line 43.
43. Okay,
44.
let's take 44. So you have
Yes, you can
okay.
see we linked a lot of class from OData core.
Yeah.
It's from OData core and add it into a link.
From the core
So,
library.
yeah, it's better to open the solution in the Visual Studio to understand the project
Yep.
to the client.
Yep.
Because from GitHub repo, you cannot see all the class in the OData client folder.
That's right. Let me tell you this. Okay, so let me tell you this. Here's this first piece here. Let's just take this easy and actually, we can have actually a couple of actionable items and out of this, and we can simplify things a little bit. Let me look at the stuff that we talked about today, on this term here. So from a URL query, AST to link, and then iQueryable, and then I will connect with you again with some with a prototype, right? A simple prototype will extract all these libraries and put them into one simple library that people can pull in because you know what, Sam, like these things in here, remember how I was saying we're trying to be technology agnostic, right? If we extract this library, right, it doesn't really matter whether that URL query is coming to you from ASP.NET URL or a graph or a GPRC or WCF, as long as you get that input, that little string that has that query, that's it. You're all set. It doesn't matter what your base URL is or how it came to be. And that's basically what's going to guarantee this agnosticness of the technology, right? Because now you don't have to be dependent on ASP.NET anymore. You can literally have OData running in an Azure function, for instance. Some people would love this. Like if you have an Azure function, and this Azure function basically just have a query that can go through, right? And it picks up that query and executes, the query on the Azure function, and it turns it into iQueryable, and then it goes and talks to the database. Something like this is huge for a lot of people, not just the GPRC or all that. So let me do this. I have some homework here. I'm gonna go and write or extract some of that code, and then I'm gonna share this with you. I'm gonna create a little repo. I'm gonna call it OData NxT dot server, and basically I'm gonna extract some of that code in, and then you and I will work together to see if we can actually have. It needs to be really simple, Sam. Stupid simple. Like basically, I pass in a string in as a query, and it basically spits out an expression. It basically spits out a link. This is it. This is our product right here. This is the piece. The piece is, you have a very simple library that gives you an interface. So this here at the very bottom here, you would have a library, and this library has an input. Watch this, Sam. This is basically the picture here. The input will be something like filter name equal Sam, like this. I think it's single quote, Sam, right? It's single
Single quote,
quotes.
yes.
Yeah. And then it spits out from the other side this expression that you just talked about, which is basically it would go and say, you know, the expression would be e.name equal Sam.
That's double quote.
Double quotes, exactly. Thank you. Yep, exactly. Double quote. A library like this, and we can call this OData NxT server or whatever we want to call it. It's basically an extraction. And now we can take this library, Sam, and we can put this anywhere. It doesn't have to be ASP.NET. It doesn't have to be anything. It can be literally anything. It can be a console application. Literally a console application that says pass in arguments as input parameters, and it will take that and turn it into an iQueryable that can execute. What do you think about that? Is that cool or what?
Yeah, we have the same idea to create a single package to process link expression for the OData query. It seems OData.NxT server, you want to combine OData link, OData query option parser and the Web API link expression together into one project.
Yep. But
yes, that's one of the idea originally at my side. When I first design the Web API OData 8.0. However, we lost a peer, so we don't have enough resource to rethink it again.
Well, you got me now.
Yeah, to be honest, that's one of our goal. We want to build a library like this. Since you have a motivation, so it's great to hear that. So we can work close to do that.
Absolutely.
But for our library, we can from left to right. We also want to make the library from right to left.
Exactly. That the next one, it would be OData NxT.Client.
The double arrow, the line.
So it would be
the double link.
Yep. It would be the opposite, right?
Yeah.
So you're basically taking this guy, throw it up in here, and take this guy and throw it up in here. And you basically go and say here, and you basically go and say, oh, really, I want to pass in. That would be your client.
Yeah, it means generate the
URL.
Query option, the URL query.
Yes. Okay, let me tell you this. So this is really, this piece here, Sam, that basically is the transcendence goal, which is #1 goal for OData NxT. That's transcendence right there. What we can do, my friend, is that we can basically, let me make this pretty. I like pretty things. Let's make it pretty, Sam. So, you know, what we can do here is that we can go and say, okay, this is the expression tree and this is my work. What I basically, I'm going to try to pull these together, put them together, you know, and then we will circle back. So our next meeting is to basically touch base. You know, I'll set up something with you. This is really exciting, Sam. We're basically doing great things, and people will be able to use OData across many different platforms and then many different mediums, which makes this even more exciting. I can't wait to have people kind of come in and tell us what they think and all that kind of good stuff. And hopefully people will be excited to use this new kind of, you know, permutation, kind of a new version of OData and move forward with it. Okay, my friend, I will set up the next meeting for us and I will connect with you again.
Yeah.
And once we come up with something, we can get together with Mike. We can get together with Christoph. Is that Christoph? And we can basically, you know, discuss, okay, we have this thing, let's productize. Let's put this out there. Let's see what people think about it. And like I said, you and I right now, we're basically doing something that I call building in the open, right? There's the OData team working together. This is how they're thinking. There's the thought process. You know, this is what we understand. This is the code base. We're going to go out there and build something great that people actually want to use and they can integrate in whatever platform they want to integrate it with, you know, and we'll see how far that one takes us. Okay, my friend. Sam, before I forget, you are awesome. Thank you, my friend. I really appreciate your input here, and hopefully we can take this to the next level. Okay, man?
Yeah.
Awesome.
Thank you. You're welcome.
You take care, my friend. Take care, brother. I'll talk to you later. Bye. Yeah, bye.